Welcome back to Maths for Morons. Today we are looking at the top 3 hardest GCSE Maths questions of all time. So let's begin. So this is a new series on the channel where I will take 3 very difficult GCSE Maths questions for you to try and I'll run through them. So let's start with the third hardest problem. And here we've got a hexagon, A, B, C, D, E, F. And already we know that AB equals BC and they are both equal to X. So we can already mark this on the diagram. There we go. But we also know that BP is equal to BQ, which is 10. There we go. And we also know that the angle ABC is equal to 30 degrees. So let's also quickly mark this. Okay, and then the question is telling us to prove that cos PBQ is equal to this weird expression here. So cos PBQ is this angle there that we're trying to find. So how are we going to go about doing this? So the first thing that I recommend is drawing a line from A to C and also from P to Q. Now hopefully you should start to see 2 triangles. We've got the black triangle, ABC, and we've also got the red triangle, PBQ. Now from observation, we know that side AC is equal to PQ. So all we need to do is find side AC, and then we've got PQ. So what we will do first is we will draw the black triangle, ABC, and there we go. So what we're trying to do is find side AC. Now, what is one method that we can use here? So hopefully by now you know to use the cosine rule. And essentially the cosine rule tells us a squared is equal to b squared plus c squared minus 2bc cos a. There we go. So all we need to do is, well, fill in the letters. So a squared is AC. We don't know that yet. We're trying to find that. But we know b squared and c squared is equal to x. So we can write x squared, add x squared, minus 2bc. Well, b and c are both x. So, and x times x is just x squared. So that would be minus 2x squared. And then cos, well, our angle here is 30 degrees. Cos 30. And all we need to do from here is just simplify things. Well, x squared and x squared is just 2x squared. That's easy. So we can replace that with a 2, like so. And you should hopefully know that cos 30 is equal to root 3 over 2. There we go. And then we can still simplify this a bit further. Well, the 2 here and the 2 here just cancel out. So we will get x squared root 3, or a better way of writing it is root 3 x squared. And then we can put these in brackets, so we can say 2 minus root 3 x squared. Now if you look at the proof, it says cos PBQ is equal to 1 and then minus 2 minus root 3. Well, we've already got a 2 minus root 3 and an x squared. So we're already on the right track. So let's not square root this. Let's leave it as a squared for the moment. Let's move on to the red triangle, which is triangle PBQ. So we've got P, B, and then we've also got Q. So we're trying to find cos PBQ, which is this angle here. And we know PB and BQ is equal to 10. We also know that side PQ is equal to side AC. Now we've found the square of AC, which is 2 minus root 3 all x squared. So that we will come back to. But let's just quickly write AC just so we know. And if you want to find the angle, well, we can just use the cosine rule again. But this time we have to rearrange the cosine rule. So what we will do, we will take the 2bc cos A and move it over to the left-hand side of the equation and subtract a squared and move it to the right-hand side. So let's quickly do that. We will get 2bc cos a is equal to b squared plus c squared minus a squared. And then from there, we just divide both sides by 2bc. So if I rub this out and move it over to the right-hand side, divide all of that by 2bc. Now that we have a coherent formula to use, we can just plug in numbers. So we know b and c is equal to 10. So let's quickly fill that out. So we've got cos a is equal to, well, 10 squared at 10 squared. We know 10 squared is 100. 100 at 100 is 200. Subtract a squared. Well, we know a squared is this here. So we could just fill that in. And that's why we've kept the a squared as it is. We haven't square rooted it, because we could just plug that straight in to our equation. So minus 2 minus root 3 x squared. And then we divide all of this by 2bc. Now b and c is 10. 10 times 10 is 100. Times up by 2 is 200. Okay, and then all we do from here is just simplify. It's really that simple. So what we can do is we can split up the fraction. So we've got this minus sign here on the numerator. So that tells us we can take the 200. We can divide that by our denominator, which is also 200. Subtract. And then we've got the term on the right, which is 2 minus root 3 times x squared divided by 200. So here we've just split up the fraction. And if you've got this like plus or minus sign in between our left and right term on the numerator, you can do that. But you cannot do that if it's on the denominator. Because I know that's a mistake that a lot of students make. So all we need to do now is just simplify. And we know 200 divided by 200 is just 1, nice and simple. We can't really simplify the other side, so we'll just leave it as it is. And we'll get 2 minus root 3 times x squared divided by 200. And that tells us cos a, and cos a is just cos PBQ. And then let's compare to what we're trying to prove it to. And it matches this right here. So therefore, we've got all, I believe this was 5 marks. And that is it. It's just that simple. We're just using cosine rule twice. So let's move on to the next question. Okay, so for question 2, we've got a probability question. There is a total of y counters in a box. And we know there are x pink counters, 5 blue counters, and the rest of them are green. And we know the ratio between x and y is 1 to 3. And we're interested in finding the probability that Freda takes 2 counters of the same colour. So let's begin. So the first thing that I've noticed, there are pink counters. So I'm just going to write a P for pink. Blue counters. And also green counters. We know that there's x pink counters, 5 blue counters, and we know the rest of them are green. Well, we know that the total number of counters is y. So we can say y minus x minus 5. And that will tell us the number of green counters. Now, we've also got this ratio here. X to y is 1 to 3. So let's quickly write that. X to y, 1 to 3. So that's telling us that a third of all of the counters are pink. And really another way we can write that is y equals 3x. So then what we can do is we can replace this y term here with 3x since it's equal. So let's quickly do that. And then this simplifies. So 3x minus x, as we know, is 2x. So we can replace this with 2x. And there we go, that's our new ratio. Okay, and then the next part of the question is find in terms of x an expression for the probability that she takes two counters of the same colour. And those counters are not replaced. So let's start with pink. We know that there's X amount of pink counters. I'm just going to put a P for pink here. And we know the total number of counters is 3x. Okay, and then we can multiply this by x minus 1 over 3x minus 1. And we're minusing 1 because obviously these counters are not replaced. So on the second turn, there's going to be one less counter. And if we multiply those fractions together, we'll get x minus 1 over 3x minus 1. I'm not going to expand the brackets just yet. We're going to do that at the end. But for now, let's move on to the blue counters. And we know there's 5 of them in total. And as we know, the total number of counters is y, or 3x. And we can multiply this. Well, 5 minus 1 is just 4. And then our denominator is just 3x minus 1. And then if we were to multiply this, we'll get something that's a lot more pleasant. We'll get 20 over 3x multiplied by 3x minus 1. And then we just do the same for the green counters. For green, we've got 2x minus 5 over 3x multiplied by 2x. And this time it's minus 6. Remember, we are taking 1 away from the numerator and the denominator over 3x minus 1. And then if we were to multiply that fraction together, we'll get 2x minus 5 times 2x minus 6 over 3x times 3x minus 1. And then for the final step where things get a bit finicky, we've just got to add all of these fractions together. So I'm just going to quickly rewrite all of this. Okay, and I've just written below the expression that we had. Okay, now all we need to do is just tidy things up. So what we can do first of all is get all of this into one fraction. And the denominator is just the same. So here's how we can rewrite it. We can just take the numerators and add them all together. And then divide it by the denominator. And it's a common denominator between all 3 of these terms. So that's just another way that we can write it that just is a bit nicer. So next bit, we just have to expand the brackets. Okay, so we've got x times x minus 1. As we know, that's x squared minus x plus the 20. And then we need to expand this double bracket. Well, 2x times 2x is just 4x squared. And then we do 2x times minus 6, which will give us minus 12x. The minus 5 and the 2x gives us minus 10x. And then the minus 5 and the minus 6 gives us positive 30. Okay, now what we can do is just collect like terms. And so far, I'm just going to focus on the numerator. So I'm not going to bother rewriting the fraction every time. So we've got this x squared and the 4x squared. Well, that just becomes 5x squared. Let's focus on the x's next. We've got minus x, minus 12x, minus 10x. That's minus 23x. And then we've got the 20 and the 30 giving us 50. And then what we can do is divide all of this by the denominator. Well, 3x times 3x is just 9x squared. And then 3x times minus 1 is 3x. And that, right here, is our answer. And just to double check if it's in the correct form, we wanted it in this format, and indeed we have it in the correct format. So let's move on to the final question. Okay, so moving on to the final question today, and the hardest one. It's this question, which it might look familiar to some of you. It's probably the worst question I've ever seen. So let's start. The diagram shows 3 circles, each of radius 4, and the centres of the circle ABC, such that ABC is a straight line. So going from here all the way to C, that's a straight line. And AB is 4, and BC is also 4. And we've just got to work out the area of the shaded region. So the first thing that we'll do, and this is going to look really complex, we'll draw a line from here to here, and that is also 4 centimetres. Yeah, because it's a radius, and it's the radius of the left circle, and each radius is 4 centimetres. So if we then connected this line to here, what would this side be? Well, this side is still 4, because it's still radius. And if we connected this side here to B, that's still going to be 4, because it's the radius of the middle circle. And the same here is still the radius of the right circle, and every radius of every circle here is 4 centimetres. So what do we do first? So we know that these triangles here are all equilateral because they all have the same length. They're all 4 centimetres. So therefore they must have an angle of 60 degrees. Which means this angle here will also be 60. Okay, then what can we do? Well, I don't know if you've noticed, but we have a sector. And the sector is composed of the shaded grey area and these little white segments. So first of all, we can find out the area of the sector. And the way that we can do this is through theta over 360 times pi r squared. So we know theta is 60 over 360. And then times pi. R is 4. And then squared. Okay, well, we can simplify this. 60 over 360, that's just a sixth. So we can replace this with a sixth. And then pi times 4 squared is just 16 pi. And then 16 pi times a sixth can be reduced to 8 over 3 pi. And that gives us the area of the sector. There you go, that's the area of the sector. Now what? See, we've got these white segments that we have to deal with. So how are we going to go about doing that? And there is a way that we can go about doing this, and this is where things get rather complex. So if I draw a line going from here all the way to here, we have ourselves a triangle. And that triangle is also equilateral. And then what we can do is we can take the sector and minus it from the triangle, and we'll get this bit up here. And that is equivalent to 1 white segment. So let's try and work out the area of the triangle first. So with this we can use half AB sine C, and we know A and B are both 4 centimetres. And then we've got sine 60. Okay, and then let's simplify this even further. Well, 4 times 4 is 16. Divide that by 2 is 8. And sine 60 is just root 3 over 2. And that will give us 4 root 3. And that gives us the area of the triangle. So then what we can do is we can take the area of the sector, minus it from the area of the triangle, and we will get this bit here, this sort of segment that I squiggled in. And that is equal to 1 white segment. So let's just write this down, white segment. And that is equal to, as we said, the area of the sector, which is 8 over 3 pi, minus 4 root 3. So that gives us the area of one segment. Now, how do we find the shaded area? Well, if you look at the sector, we've got two of these white segments to deal with. So what we can do, we can take the area of the sector and subtract it from the area of two white segments, and then we'll get the area of one shaded region. So let's take the sector, which was 8 over 3 pi, subtract it from two of these white segments, which was 8 over 3 pi minus 4 root 3. Okay? And then what we can do is we can just simplify this. So the 8 over 3 pi can just stay the same, nice and simple. And then we've got 2 times 8 over 3. Well, that's just 16 over 3 pi. And then we've got minus 2 times minus 4 root 3, which is plus 8 root 3. And then tidying this up, we've got the 8 root 3 on its own. So we can just deal with that. Then we've got 8 over 3 pi minus 16 over 3 pi, which will give us minus 8 over 3 pi. Now that tells us the area of one shaded region. Now, because there's two shaded regions, we need to double it. So we just need to times all this by 2. Now it will give us 16 root 3 minus 16 over 3 pi, giving us our answer. And that is all that we've got time for today, guys. Please like the video and subscribe, and I'll see you in the next one.